Kole ngambulo luku. With whatever we do. Jioni safu nola. With whatever we do. Hale yide munyu school. Nyepamne nekudlukula. Nyepangira galagena. Nyepamne nekudlukula. Ibulo kenoto ni beti sola. Ibulo kedato ni betoto.
Bege Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kama na wulo kono.
Wulo kono nyinte mo Lamin.
Pa bilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Nunda mana.
Kata.
Jamani mbere.
Lindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramu man kontan.
Ngoto minaka ngala min je fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama na benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karamungoto. Anu santeng ministry ko di ngole si suwo ko amanke ko be holi de
si bitun
bagona ringa
ala ni ko kede namo balo
ala ni na ko na karta bulo be dam ala ni je
ngodo
nam
ngoto mon kontan feren
jamani mu ne keda
ifi ka Lamin wulo ko no nyintay mon ko do fete malo Lamin nyande sila la be la moy kala karango
jamani karam wol be soron ne ko fasita wulo ko nako
baba
karam wol ma ko ni ko karam wol soron da ma holi lem ngodo dini wonyanta sila ala karango la moy yamen kamen fue man kontan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol soron do kamen courant ma ra do la kombo e ko ndol na kara mol soron je kara mol soron Lamin ada lo nyino la man tara fe na sokon ala mu nekela
Lamin ite fayda malon ko lesinol be kar radio
nga fine
e ko yana di mo Lamin
nga fine
ya mu na fonye
bi kabin mina kan ntambita nteri maning Fatu ndambite la sukala ala diningol bebe siri be la moyka
faru dan so am fana tambira jele ni subala la ngaje diningol be jet talanta nen kili warol e be serin jelet
sa Lamin farante ku kili wo keno la ba Lamin bitaka wulo ko no nyinta mo Lamin
amandara fenela
ite dine ko ni man si yakaru la suno la moy radio to balon na
mu ne ka ke afonde ma ñaara ni alon
telentel jikot
afonde ma mu ne be ke
ite balon tel be cikritel ni man karam kele yaaje nata karana mbasa malaya ay tarije
par ñaarande kombo courant ho findira kombo ide na rajede ni sonka bay ko Lamin ma ñaata la wulo ko karam mo be so dafa be
ko to wole nati bayo ngalle ni Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu wo kono bari ni ko e sisu wo kono ibe karangol dike la radio lin telel to hani tele ma to nyaay man tele soto la bungo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta yo bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
ile subjector baby jele baby jele
wala nan ka coco moy fa dan so wala ngombe tambi ka nga dinni wolde be ikadum bungo ko kala
ma asototal de
Lamin mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sinila mba ndele sinilo na ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fadam bulata ko ko me yen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bulay kara wulo kana ta kila ya bambalo yo be bulaje koto dinni ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro Lamin nyanta kara si so na radio
la sila le ayala le sino
ndal ko korno ko smolo
kila
be bin ko mo mo say mi do ni ko no kera
mengi bruzo
ndal ko ro la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan yo nyara nyar wo ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
ja image nañu ñambol si zol le keje kisigi man si zol no le kafun ka ñowa bari ñambu kino ni mañana ka finde ni nambe ko zol la ga
ngalle limbeta de be ñambo do dilanna
ñara nim ko ridin fennat ñara nata
bari famo ke da
ngata bungono Tami bungono nyara ngando ko fele ko ke baru nganda ni pelo landi jak
iyo awa
la bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro ta
Hello, my name is Mr. Yusuf Ajalo, and I welcome you to my chemistry class. And in our today's lesson, we're going to look at organic chemistry. And the family of organic chemistry that we're going to look at today are called alkenes. Alkenes are hydrocarbons that contain a carbon-carbon double bond. And the carbon-carbon double bond characterize alkenes, the functional group in alkenes. And it is also called an unsaturated hydrocarbon because of the presence of the double bond. So a carbon-carbon double bond is both an important structural unit and functional group in organic chemistry. So they form a homologous series with the general molecular formula CnH2n, where n is a positive integer and n starts from 2 and so on. Okay, so next we're going to look at the nomenclature of alkenes, that is the IUPAC naming of alkenes. Okay, here we're going to follow a set of rules or series of rules that are observed in the naming of alkenes. So the first thing we need to consider here is we give alkenes IUPAC name by replacing the ane ending of the corresponding alkene with ene. That is, alkenes has the suffix ane, and this we're going to replace with the suffix ene. So the simplest alkene is ethene, commonly called ethylene, in which both carbons are sp2 hybridized. That is, this is the structure of ethene. Et is the prefix for 2, that is 2 carbons, and then the suffix ene means it has a carbon-carbon double bond. Okay, so the prefix eth means the number of carbons, and then F stands for 2 carbons, and then the suffix ene represent what? The double bond, which is the functional group. Okay, if this was an alkene, the corresponding alkene would be named as ethene, where the ane suffix means carbon-carbon single bonds, which are alkenes. But since we are looking at alkenes, in naming the corresponding alkene, we drop the ane ending and then add ene. So instead of this being called ethene, we call it ethene. Okay. Then we're going to consider the longest continuous chain, which includes the double bond forms the parent name of the alkene. So the parent name of the alkene must involve the double bond, and it has to be the longest continuous chain. So the chain is numbered in the direction that gives the doubly bonded carbon their lowest number. So meaning the double bond should take precedence. The double bond should always be given the lowest number. And let's look at this example here. If you look at this compound here, this compound is an alkene. Why? Because of the presence of the carbon-carbon double bond. So how do we name this alkene? Like we mentioned earlier, the longest continuous chain that includes the double bond forms the parent name of the alkene. So if you look at this double bond here, it is connected to these 2 carbons, or it is in between these 2 carbons. But then the continuous chain is more than 2 carbons. So the continuous chain is made up of 1, 2, 3, 4, 5 carbons. And then the parent name or the root name for 5 is pent. Okay? And then we should give the lowest numbering to the functional group. And what is the functional group here? is the carbon-carbon double bond. So we should look at this and count from both sides. We count from left and we count from right and see which side gives us the lowest numbering, and we use that as our naming of what? The alkene. So if you start from our right, this is going to be, sorry, from our left, this is going to be carbon number 1, 2, 3, 4, and 5. If you start from our right, this is carbon 1, 2, 3, 4, and 5. Okay. So starting from our right, the first carbon that shares the double bond is carbon number 4. Okay. And if you start counting from our left, the first carbon that shares the double bond is carbon number 1. So here we look at 1 and 4. 1 and 4, which one is lower is 1. So therefore the numbering will be from our left. So we give the lowest numbering to the functional group. And the lowest numbering or number to the functional group here is 1. So this is going to be called pent 1. Then the suffix ene means double bond. So we're going to write ene. Okay. So the name for this compound is pent 1-ene. It can also be written this way. We can write the number first, that is 1, which is the position of the functional group, and then pent, which is the root name or the parent name of the compound, or we call it a prefix, Greek prefix, which means 5, and then ene, which is the suffix for alkenes. Okay. So this can also be called 1-pentene. Also, the carbon-carbon double bond takes precedence over alkyl groups and then halogens in determining the main carbon chain and the direction in which it is numbered. Okay. Let's take another example. Let's take this example. Let's look at this compound and try to give it a name. Okay. So we said the double bond takes precedence over alkyl groups. This is an alkyl group, or halogens. So here we don't have a halogen, but instead we have an alkyl group. So considering this compound here, to name this compound, we have to give first, the double bond has to take precedence. So we have to give the lowest number into the double bond before we consider the alkyl group. The alkyl group is our substituent here, which interrupts what? The longest hydrocarbon chain. So we try to number them both from left hand side and then from our right hand side. So let's start from our left. Starting from our left, this is going to be carbon number 1, carbon 2, 3, 4, and then 5. If you start counting from our right, that's going to be our carbon number 1, 2, 3, 4, and then 5. So meaning the longest hydrocarbon chain here is made up of 5 carbons. Okay. So we know our root or the parent name. The prefix is pent, which means 5. Okay. Now let's try to give precedence to the double bond. So doing so, if you should start counting from our right, this is carbon 1, 2. So the first carbon that shares the double bond is carbon number 2. And if you should count from our left, the first carbon that shares the double bond is carbon number 3. So if you compare the two numbers, that is 2 and 3, 2 is lower than 3. So that means our counting will be from our right. So that means the position of the functional group is 2. And then the suffix for the functional group is E and E. Okay. Now, we have an alkyl group here, which is part of the longest hydrocarbon chain. So we refer to it as a substituent. We need to mention the position of the substituent as well. And looking at this structure here, we are counting from our right. So therefore, the substituent is going to fall on carbon number 4. Okay. So the position of the substituent is 4. And then the name of the substituent will be based on how many carbons is the substituent made up of, the alkyl group made up of. So here we have only one carbon. So the prefix for 1 is met. Since it is an alkyl group, we'll add the suffix YL. Okay. So let's put this together to give a name to our compound. So how do we name this compound? In naming, we name the alkyl groups first. So that means we have to name this first. That's our alkyl group. And then we have to mention the position of the alkyl group, which is 4. So this compound will be named as 4-methyl. And then what is the position of the functional group? Is 2. And then what is the root name or the parent name of the compound? Is pent, which is 5 carbons. And then the suffix for alkenes is ENE. Then we add ENE. So therefore, the name of this compound will be 4-methyl-2-pentene. The 4 means the position of the substituent. The 2 means the position of the functional group, which is the double bond. And then the pent is the number of carbons, 5 carbons. The root name for 5 is pent. And then the ENE means the suffix of the functional group. Okay. So we name this compound as 4-methyl-2-pentene. Let's try to give a name to this compound. So what is the first thing we need to do is to identify the longest hydrocarbon chain. And then the longest hydrocarbon chain must consist the double bond. Okay? So the carbon-carbon double bond should be part of our longest hydrocarbon chain. So that means this part here should be part of the longest hydrocarbon chain. So let's try to give it the numbers and see which will give us the highest numbering. So this is going to be 1, 2, 3. If it should go that way, we'll have 4 and then 5. But if it should go towards our left, we'll have 4, 5 and then 6. So we have 6 against 5. Okay. So 6 is greater than 5. So the longest hydrocarbon chain will be made up of 6 carbons. Okay. So we have identified the longest hydrocarbon chain. That is that. So therefore, this group here is going to be termed as a substituent because it's not part of the longest hydrocarbon chain. And this Cl here as well is a substituent. But before we consider the substituents, we first need to consider the double bonds. That is the alkene, the functional group. Okay. So if you should start counting from down here, the first carbon that has the double bond is carbon 1. And if you should start counting from down there, this is going to be 1, 2, 3, 4, 5. So the first carbon that will share the double bond is 5. And of course, 1 is lower than 5. So therefore, we start counting from carbon number 1 there. Okay. So now we have identified the position of the functional group. But what did we identify first was the longest hydrocarbon chain, which is made up of 6 carbon. And the prefix for 6 is hex. Okay. And then the position of the functional group is on carbon number 1. And then the suffix for the functional group is ENE. Okay. And now we're going to consider the substituents, which are the groups that interrupts what? The longest hydrocarbon chain. So the first substituent here, which is organic, is on carbon number 3. So 3, and then it is made up of 2 carbons. And then the prefix for 2 is et. So since it's an alkyl group, we will add the suffix YL. So on carbon number 3, we have an ethyl group. And we also have another group, or an atom, which is chlorine. And this chlorine is on carbon number 6. So we call it chloro. So now we have identified the longest chain, which is hex. And then we have identified the position of the functional group, which is 1. We have identified one of the substituents, which is organic, is on carbon number 3. And then another substituent, which is inorganic, which is on carbon number 6. Now let's try to put this together to give a name to this compound. So how do we do that? If you have substituents which includes or involves organic and inorganic, you name the inorganic first, then the organic. So how do we name this? We're going to start with the chloro. And what is the position of chloro? Is 6. So we'll have 6 chloro. And then what other substituent here is an ethyl group, which is on carbon number 3. 3 ethyl. And then the longest hydrocarbon chain is 6, which is hex. And then the position of the double bond is 1. So I'll write 1 hex. And then the suffix is E-N-E. So we name this compound as 6 chloro 3 ethyl hexene. That's our first structure. Let's give it a name. So the first thing we need to do is to identify the longest hydrocarbon chain. And then of course the longest hydrocarbon chain must include the carbon-carbon double bond. So let's try to break this down. We'll have CH3, CH, CH, CH2, C. So the carbons or the group in bracket is all attached to this carbon. So it means you have 3 of this group attached to this carbon. So we'll show that. And then, so the structure looks like that. Okay. So now let's try to give it a name. But before we do so, we need to identify the position of the functional group. We need to identify the position of substituent if there is any. And looking at this, we have 2 substituents which are not part of the longest hydrocarbon chain. So here, let's try to number it so we can give the lowest number into the functional group. So if you should start numbering from our left, that's going to be carbon 1, 2, 3, 4, 5, and then 6. And here, this is going to be 1, 2, 3, 4, 5, and then 6. Okay. So starting from our left, the first carbon that shares the double bond is carbon 2. And starting from our right, the first carbon that shares the double bond is carbon number 3. So we have 2 and 3. 2 is lower than 3, so we should take the counting from our left. Now, if you should take it from our left, the functional group is on carbon number 2. So we'll have 2 and then the suffix ENE. And on carbon number 5, we have 2 substituents, which are of the same type. They are all organic and then they are all made up of or consist only 1 carbon. So on carbon 5, we have a methyl group. On the same carbon 5, we have another methyl group. Okay. So this we're going to put together to give a name to the alkene. But we forgot to mention the number of carbons. So the number of carbons here are 6. So this is going to be hex. Hex is the prefix for 6. Okay. So we'll join this together to give a name to our compound. So we start with the alkyl groups first. We always name the alkyl groups first. So the first alkyl group is on carbon number 5. Another alkyl group is on carbon number 5. Then the two alkyl groups are the same, so we use the prefix di. Di means 2. Then we'll have dimethyl. The lowest numbering for the functional group is 2. Then we write 2. And then the longest hydrocarbon chain is 6. We write hex. Then we add the suffix e, Ne. Okay. So the name of this compound is 5,5-dimethyl 2-hexene. So what do? We give the lowest number into the functional group. That is the carbon-carbon double bond. So if you should count from our left, the first carbon that says the double bond is carbon number 2. If you should count from our right, the first carbon that says the double bond is carbon number 2. So from both sides, it's going to be 2. Okay. But there is a substituent here. Now we want to consider the substituent as well. We want to give the lowest number into the substituent as well. Since the lowest numbering for the functional group from both sides is going to be 2. Now we consider the substituent. So to give the lowest number into the substituent, if you should count from our left, it's going to be 3. If you should count from our right, it's going to be 2. So that means the counting will be from our right. So we can give the lowest number into the substituent. So meaning the substituent here is on carbon number 2. And the substituent is chlorine. So we write 2-chloro. And then the longest hydrocarbon chain is 4. So the prefix for 4 is but. And the lowest position for the functional group is 2. Now we put this together to give a name to the compound. So what do we name first? We name the substituent, which is chlorine here. So it's going to be called 2-chloro. What is the position of the functional group? Is 2. And the number of carbons is 4. And the prefix for 4 is but. Then the suffix for alkenes is Ne. So this will be named as 2-chloro-2-butene. And let's look at the fourth and then the final example.
Anybody recording?
So this is our final example. The same, we're going to follow the rules, right? That is to give the lowest number into the functional group. So that means we should count from both sides, and then we should consider the longest hydrocarbon chain as well. So in considering the longest hydrocarbon chain, we are giving precedence to the carbon-carbon double bond. So that means if you should start counting from here, this is 1, 2, 3, 4, 5. But if you should go this way, we'll have 5 and then 6. Okay. So we have 6 against 5 carbons. So the longest hydrocarbon chain will be made up of 6 carbons. Okay. And then to give the lowest number into the functional group, if we should start counting from down here, carbon number 2 says the first carbon that says the double bond is on carbon number 2. And if we should count from our left, 1, 2, 3, 4. So the first carbon that says the double bond is carbon number 4. So 2 is lower than 4. So we count from down there. Okay. So let's first identify the longest chain. The longest chain is made up of 6 carbons. So we write 6. And then the prefix for 6 is hex. So instead of writing 6, we write hex. And what do we do next? We give the lowest numbering to the functional group, which is 2 here. So the functional group is on carbon number 2. Then this group here It's not part of the longest hydrocarbon chain. So we name it as a substituent. And then we need to give or mention its position. So this is attached to carbon number 4. So we write 4. And then the group is made up of only one carbon. Then the prefix for 1 is met. And then since it's an alkyl group, we'll add the suffix YL. And there is another substituent, which is an inorganic atom, which is bromine. And we need to mention the position of bromine. Bromine is bonded to the preceding carbon. That is carbon number 5. So that means on carbon number 5, we'll have a bromo. Okay. Now we have identified the longest hydrocarbon chain. We have identified the position of the functional group. We have identified the position of each of the two substituents. That is bromo and then methyl. So now we're going to join things together to give it a name. So how do we name this? We first name the substituents. And then here we have two different types of substituents. One is organic, the other is inorganic. So we name the inorganic first, then organic. So to name the inorganic first, the inorganic is on carbon number 5. So we write 5 bromo. The organic is on carbon number 4. We write 4 methyl. And then the longest hydrocarbon chain is made up of 6. We write hex. Sorry, before writing 6, we mention the position of the functional group, which is carbon number 2. And then the longest hydrocarbon chain is 6, which is hex. Then the suffix is ENE. Okay. You can write this in another way around. You can write it as 5 bromo, or you can name it as 5 bromo, 4 methyl, hex, 2 in. So either way is correct. You can first write the position, then the parent name, or you can first write the parent name, then the position of the functional group. First, we're going to look at the industrial method. Industrial method of preparing alkenes. Okay. So how do we prepare alkenes in the industry? Alkenes can be prepared in the industry by thermal cracking. And what do we do in thermal cracking? We dehydrogenate alkenes at a very high temperature. Let's look at this example. If you should have this alkene, if this alkene should undergo thermal cracking, that is breaking it down using very high temperatures. Okay, let's assume this happens at 850 degrees Celsius. This alkene here will undergo dehydrogenation. Okay. This is called propane. Why? Because it is composed of 3 carbons, 1, 2, 3. And a prefix for 3 is prop. And then it is made up of carbon-carbon single bonds. And then the suffix for carbon-carbon single bonds is ANE. So we name it as propane. So when propane undergoes thermal cracking, propane will undergo dehydrogenation to produce an alkene. This alkene is made up of 3 carbons, and then the prefix for 3 is prop. And then since it is made up of carbon-carbon double bond, the prefix for suffix for carbon-carbon double bond is ENE. So we name this as propane. So this is an example of what? Industrial method of preparing alkenes from alkenes using thermal cracking. Another method of preparing alkenes we're going to look at is laboratory preparation of alkenes. Alkenes are prepared in the lab mainly by dehydration of alkanols. Alkanols are organic compounds that has OH as their functional group, the hydroxyl group. Okay. We can dehydrate, that is removal of what? A hydrogen and then hydroxyl group to form water from an alcohol to make alkenes. Let's take an example of this reaction. If you should have, let's say, propanol, this is prop because of the carbons 1, 2, 3, and then we drop the E from the corresponding alkene. If this was an alkene, it is going to be called propane. So we drop the E from the corresponding alkene and add OL. So the compound is named as propanol. Propanol can undergo dehydration reaction when you react it with concentrated H2 sulfuric acid. This compound here is a dehydrating agent, so it's going to remove a water molecule from the alcohol. But how does it do that? It removes the OH from the carbons that bears the functional group, and then a hydrogen from the adjacent carbon. So here, this is the adjacent carbon to the carbon that bears the functional group. This is the carbon that bears the functional group. That is, the OH is attached to this carbon, and then the adjacent carbon is the carbon before. That's the preceding carbon. So from the preceding carbon, a hydrogen will be removed, and then the OH will be removed from the carbon that bears the functional group. So therefore, we'll have this as our molecule. And this reaction is called dehydration of alcohols, and it produces an alkene. So we can use this method in the lab to prepare alkenes. The process is called dehydration of alkanols. Another method of preparing alkenes we're going to look at is dehydrohalogenation. This is another laboratory preparation of alkenes. Dehydrohalogenation, meaning removal of what? A hydrogen and a halogen from a haloalkene. Okay. When you have a haloalkene, we can prepare alkenes using haloalkanes through this process, that is dehydrohalogenation. Okay. So this is the loss of a hydrogen and a halogen from a haloalkene. Let's look at this as our example. This compound is a haloalkene, and we name this compound as 1-chloropropane. When this reacts in the presence of what? Potassium hydroxide dissolved in ethanol, this will produce an alkene. So here as well, dehydrohalogenation reaction occurs. That is the loss of what? A halogen and then a hydrogen from the adjacent carbon. So this is the adjacent carbon to the carbon that bears the halogen. So a hydrogen will be removed from that carbon, and then the halogen will be removed from the carbon that bears the halogen. So therefore, that will produce us HCl. But we are more interested in the organic compound, that is the alkene, because we are looking at what? The preparation of alkanes. Okay. So this method can also be used in the lab to prepare alkanes.